So this is now 3:30 talk with Harrison and Erlend. And the talk is called So Long and Thanks for All the Fish. All right, give these guys a good, this is our first talk, so give them a good warm round of applause. They're from Deutschland. Good luck, guys. Yes.
Hello. Is the sound okay?
Good.
Thank you everyone for coming to our presentation called So Long and Thanks for All the Fish. This presentation is about the story. It's a storytelling presentation where we will guide you through all the steps that we had to go through from receiving a text message to identifying scam ring and the people behind the software. So my name is, does the clicker work? No. My name is Erlend. I work in a security company called Mnemonic in Norway, where I do pen testing.
Yes, and my name is Harrison, and I do the exact same thing as Erlend. And for those of you in the back here, here's what we look like.
So our project, it started back in the end of 2023. And at that time, it was like a pandemic of phishing messages where people would send you text messages about packages in the mail with a link, and you needed to pay some postage fee or something. And on the screen, it's like the message that we received. I received it personally, and it's from the Norwegian Postal Office. And they want me to click this link and fill out my credit card details. The news coverage at that time was very scarce. It told you basically two things. You should not click the link and you should delete the message. And we found that a little bit upsetting. We really wanted to know what can we find out if we click the link and used our skills to see what was really going on. So we felt a bit, what you can call it, courageous, and we decided to not follow all the advices, and we clicked the link.
All right. So we clicked on the link, and as you expected, you got a page for the a website basically pretending to be the postal service showed up on our phone, and it was, the example that we had was for the Norwegian Postal Service, but just imagine, this applies to any country on the planet. There's different templates that exist. So it worked on the phone, and then we loaded it up in our browser. So we mainly work with web application security. So the first thing you want to do is load it up into Burp and kind of see the traffic going back and forth. Unfortunately, the first thing we got was this not found page, which was a bit disappointing. We figured, okay, what's the difference between what we're sending and what our phone is sending? We tried changing the user agent to see if they were checking that. Unfortunately, that didn't work. But then eventually we found that they were checking two things. It was the user agent, and then they were also, what we think they were doing was checking that it was coming from a mobile network, so that if you were connecting from like Wi-Fi or whatever, because they were sending it to your phone, right? So they expect you to come from a mobile network, so they checked what IPs, and I think that's probably to prevent people from spamming with fake data, maybe, I don't know. So now that we had the website up and running, we could see the traffic moving back and forth. Maybe some of you are familiar with this. They were using a standard library called Socket.io. For those of you not familiar, it's basically just a framework for sending messages back and forth between a browser and a backend web server. One of those messages looked like this when we were kind of filling out the form. If it looks like nothing to you, it almost looked like nothing to us. It was basically a bunch of obfuscated data going back and forth. So we decided to break it down. What exactly is going on here? So we kind of went through each part of the message bit by bit. So there was a type field, a data field, a user field, and a room field. Type and room just looked like a character set and length for maybe an MD5 hash, and data looked like it was base 64 encoded. If you decoded that string, you got it started with some ASCII text that said salted, and then a bunch of garbage, so we figured some kind of encryption was going on here. So obviously, another layer of obfuscation, and that's kind of a reoccurring theme. You'll see a few different scenarios throughout the presentation where they really try and add a few steps just to make it a bit more difficult to figure out what's going on. So we wanted to dig a bit deeper into the obfuscation. Because they were doing encryption, and because the encryption was being done in the browser, we figured there's probably going to be some keys sitting somewhere in the JavaScript. So we went into the developer options. We found some functions called encrypt and decrypt. We set a breakpoint. And then anytime that encrypt or decrypt function gets called, you can see what gets passed in. And normally that's going to be a key and the data that you want to have encrypted. So that's exactly what we did. And then you can see on the right-hand side, you see sync data. That was actually the key. And then there's a JSON blob underneath that, and that's the data that they were asking to get encrypted. And this is basically just the phishing data that's getting sent back and forth. So if you type in your name or address or whatever, that's what's getting encrypted. So now that we had a key, we made a small JavaScript utility where you could just type in that encrypted string, and it would spit out the plain text back. So to kind of summarize what everything is going on here, we were able to find in the JavaScript that type was actually another string, sync data. The data looked like this, and room was actually admin. So now we're kind of seeing like logically how they're maybe thinking about building this application. So you have, you're sending messages to an admin room. So this is the kind of like real time. So as you're typing in the data, type in your name and address, you can see with each character like entered into the field, a message is sent over WebSockets. So at this point we figured, okay, there's probably a backend that's receiving this in real time. Maybe there's, kind of like some admin panel.
Yeah, and also when we talked with some people, they felt that they were not phished because they never pressed the submit button. They might getting second thoughts at the final field. But as you could see, it was always already too late because you kind of had submitted the text without pressing enter.
Yep, so here's just another example where you can see as you started filling out data, you have 1, 2, 3, 4 MAI. I didn't finish typing in the address there, so yeah, just an example of what you can see. So we kept digging. When you first opened the page, it sent a different type of message, and this was a join command, whatever. I mean, they made this, so we're still trying to figure out how it was put together. But you're joining a room, but that string was empty. So we're sending messages to an admin room, but we're joining a nothing room. So it's like, okay, what if we replace that text and just join the admin room? And this is exactly what we saw when we joined the admin room. It was a real-time stream of everybody that was connected to that phishing site as they were typing in their name, address, credit card data, everything, and you could see it character for character as they were typing it in, just like you saw when we were kind of demoing how you got phished. So this is blurred for obvious reasons, but this was an actual video feed we took when we saw what was going on. Then we started to like try and take apart, okay, what are in these messages? So aside from the phishing data, there were some debug messages, basically, kind of like messages between different application components. So they weren't just using it for the phishing data. So this was a message. It's not exactly the one that we saw, but it's very similar. Unfortunately, I don't have a proper screenshot. But basically, in that data field, instead of those characters there, it was a debug message for a database. And it had the name of the database that it was sending those debug messages to. And the name of the database was Darcula. And it stuck out to us. Like, what is that? Is that the name of the software? Don't know. We started Googling. Maybe some of you know. Darcula is also the name of a theme for VS Code or IDs. So it was just drowned, nothing relevant really there. But then we thought around this time, criminals like to hang out on Telegram. So we typed in the word Darcula into Telegram.
So the two results that we got, it was a username called Darcula, and he was the administrator of a group called Darcula that had almost 500 members at that time. In this group, all the members, or very many of the members, like to brag about what they were doing, were showing off. This was the Android phones that they would use to send the RCS messages with. You can see that they have put some green tape over the camera, so they are a bit cautious about what they're doing. They posted pictures of their setup with mobile modems, bunch of SIM cards in boxes, iPhones, iPads for iMessage. The servers, we don't know, but we guess they are using those to emulate Android devices. They also showed what they did with the credit cards that they received. When we saw this, we were a bit baffled because we didn't think it was possible to add that many cards to a phone without getting some fraud detection or something like that. And it hadn't occurred to us that by adding a card to your Google Wallet or on your Android or iPhone, that you only need to get a validation PIN once. And then you can continue to use a stolen card forever without actually being challenged with a new PIN. They would show the bank statements, how they would use these credit cards to cash out on terminals, how they would spend your stolen money on the first-class tickets and bars, nice cars, parties, and other versions of Las Vegas. But the user Darcula, what we believe to be the developer of this phishing kit back then, he was quiet. He did only post technical stuff, and the pinned message was installation instructions on how you should get this phishing kit installed on your own Linux server. So it was a simple one-liner. You would execute this command on your rented Linux virtual machine, and moments later you would have a working copy of the phishing kit. But it was not licensed yet. Yep. Harrison will get into that now.
All right, so digging a bit into the phishing platform now that we had a copy running on a server that we controlled. So, as Erlend mentioned, it was an easy one-liner. You just run it, and then they give you a URL so you can log in. So there's a hidden backend admin panel with a unique URL unique for each server. They give you a username and password. This is what it looks like when you log in. So the video here, it's a blank server, nothing's been configured, but just kind of showing you what it looks like, going step by step through all the different menu options. We were a bit surprised. It was actually like quite well developed. You could even back up all of your stolen data to Telegram in case your server got taken down. Yep. But as Erlend alluded to, in the bottom left-hand corner, you see a big red box. And if you don't read Chinese, it basically says you need to pay for a license. But now that we had, we had the software running on our own server, we could dig a bit deeper into the backend to see what kind of code it was running. It was written in Node.js. This is what the code looked like. Another example of obfuscation, just a bunch of nothing. We found out that they were using an obfuscation tool called JavaScript Obfuscator. It's an open source project. You can just download it from GitHub. There's also another open source project on GitHub called Synchrony. And it basically just does the exact opposite of what the JavaScript obfuscator does. So you just take the obfuscated code, you put it in, and then you get then you just get more or less normal Node.js code back out again. So now we could look at the code and actually see, okay, what's going on? What kind of functions does this application have? So I'm not going to get too much into the weeds here, but basically what this arrow is pointing to is a part of the code that handles activations. And not just client activations, like I'm running a client and I need to activate against a licensing server. This actually contained code to be the licensing server. It was the same code base. So what it did was it checked, like, is my host name the host name of the licensing server? If yes, then enable a hidden menu, and you can issue your own licenses to run the software. Not the best visualization here, but basically we just made some Nginx configurations and tricked it into thinking it was its own authorization server. Supposed to be playing, maybe?
Let's try next slide, see
yeah.
what happens.
There we go. Okay, so now I got two tabs. One is the regular server, and one is the authorization server. So now you see a hidden menu. And then you can click on a button that says, like, generate new license key. You give the license key a name. You give it an expiration time. Normally licenses are issued for a few weeks at a time. We just said a few years. You get the license code, and then you can go back to your same server, but you go back to your phishing server, click on the red button, paste it in, and now you have a green box, which is good. So now we could use the phishing platform like to its fullest extent, like emulating actual phishing sites. And back to Burp again. So we mainly work with application security. One of the most basic first checks that you do is kind of playing around with authorization. Do they check that you're actually, are you providing a valid token? So you see that admin token line there. If we remove it, they give you a 401. You need to log in. Good for them. However, we read through the code and we found out that there was a if statement on that authorization check. And it says if the host header is this value here, localhost, and if you provide a refer header that you can see here, then you don't need to check for admin token. So then you can see so basically we took away the admin token, we provided these two headers here, and then now you can use the API as if you were logged in as a phisher or a scammer.
Yeah. So the way this ecosystem worked was that there were servers on the internet. It was servers for the licensing. It would be servers for hosting the installation files, the Docker images, and also the individual pages that impersonate well-known brands. We were interested in finding the licensing server because, as Harrison just showed, you would fill out a comment, and we suspected that the people behind it would use it for bookkeeping to keep track of who had bought the different licenses. So we would try to find it on the internet amongst all IPs on the IPv4 space. The server itself was hidden behind Cloudflare, and we wanted to see if we can find it, the origin IP that is not behind Cloudflare. Since the application was containerized, it meant that every installation was unique, and as we saw that the software was dual purpose, we knew that it only required to be configured with the right host name, so we suspected that the same setup was used also for the licensing server. We made a single fingerprint and used Shodan to search for servers that matched this fingerprint of technologies. We had about 800 results. Few of them were false positives, but with this we were able to find all the phishing instances on the internet. And we already knew the API fairly well, so we could interrogate each and every one and see, are you the licensing server? And we kept on going until we found it. It was hosted in Los Angeles by Multacom, that is in the Ian building. On the marketing material, they say it's on the 4th floor, if I remember correctly. Yep. We suspect it is actually hosted on the left bottom image.
Hiding behind the guy.
Yeah, it's just a joke, but it's in this floor somewhere, according to the marketing material. And we were able to extract all the licenses, so we could see that in a period of, I think it was 4 months, they had issued over 5,000 licenses, and we could see who had bought them and also where it was activated from.
Yep. So yeah, just one comment on that last slide. You could, I know it's a bit small, but you have the license key, you have the Telegram handle for all the users, and the date and time it was valid for, as well as the IP that was activated. So that's the origin for every single phishing server. So good, nice information to have. So with all of this, we figured it was a good time to talk to the police. So we put a 24-page report together. Erlend and myself, we're based out of Norway, so we initially contacted the Norwegian law enforcement, even though this is a global issue. So we shared it with a few agencies there. We talked with Europol. Europol also distributed to the FBI. Europol invited us to The Hague, so we each flew out once, so we were there twice. We had good discussions with them. They were quite happy to receive the information. In the end, we kind of learned that they said thanks, and that was that. So we kept poking around ourselves. Now, because we had API access to the licensing server, we wanted to see, okay, what other data can we get out of this? This message here was it was in the access logs for the licensing server. It logs the IP address, the user agent, host header, and basically that there was a not found error. And what we think happened here was that there was an admin logged in, right? Because you can see that unique URL, so you know that somebody knew this secret. And they were accessing a JavaScript file that didn't exist. So maybe there was a mismatch between, maybe he updated the software and it had a unique JavaScript, but the client wasn't updated, so it asked for something that wasn't there. Anyway, it generated this not found error. But the IP of that not found is the IP of the admin who logs into the licensing server. So this is the IP, that's basically their internet IP for their, yeah. We looked it up on Shodan. It was a virtual server hosted in Alibaba Cloud in Hong Kong. We didn't know too much about this. We figured, though, it was going to be some type of VPN. We weren't sure if it was a private VPN that was set up or if it was like an exit node for lots of VPN users. In China, if you're located in mainland China, it's quite common, especially if you work in tech, to set up a VPN server so that you can access Western sites to basically get access to what you need to do development. So we figured maybe this is what he's doing. We looked, we're going way down the rabbit hole here, saying what else is associated with this IP address. Mnemonic, we have a passive DNS service. There's lots of them out there, but basically what it is a historical record of DNS records saying this IP was associated with this domain name back at this point in time. So we were able to see that about a year prior to our research, it was associated with a domain here, ifshe.com. Had no idea, maybe like most likely in the cloud. IPs get reused, don't know. But we also just kept going because we didn't have much else to go on. And we saw that this domain was also associated with a GitHub account. So we went to the GitHub account. Way down the rabbit hole here, really like pulling at the threads here or straws, but basically we did realize that going through the projects on this GitHub page was that this developer focused on a lot of the same technologies that the Magic Cat software was written in. Going through what was posted on GitHub, if you clone the repository and look through all the commits, sometimes there's email addresses there. We found this. It said myforcheng@gmol. Figured it was a misspelling, so we fixed that and put it into a tool called OSINT Industries. So if you don't know what this is, it's basically, you know, like when you go to Google and you say, hey, I forgot my password. So you type in the email address and they're like, okay, we're going to send an SMS message to blah, 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 number ending in 123. They basically do this at scale for a ton of different services. So you can kind of map out where this address is, or where this email account is used. We found it was used in a lot of places. What was interesting was that there were some phone hints. So there was a PayPal account where you can see there's a Chinese number. There was a Apple account, looked like a US number potentially. The US number stood out to us because we had seen it before, or at least part of it. On the Telegram profile for Darcula, like the user we knew was a criminal, there was a mobile number. We had already looked into it, but it pointed at a Google Voice number. We figured it was kind of like a burner VoIP number, didn't really mean too much. But then we saw, oh, okay, it has the same one that's associated with an Apple account. Maybe we're onto something. Maybe this could be the same guy. But we still weren't really sure. So we sent him an email. And we said, hey, we got a problem with one of your GitHub repositories. Can you like help us, whatever, here's a link to whatever. And it didn't do anything. I think it just redirected to Google or something. But it was a URL shortener, and it just logged the IP address that clicked on the link. And the IP address that clicked on the link was the same IP that we saw logging into the backend licensing server for Magic Cat. So we felt pretty certain at this point, okay, we're on the right path. We were looking through the Internet Archive, trying to see what else was associated with these accounts that we had found. There was an old blog with like a contact me button, so we found a QQ account, which is a common email platform in China. We looked at this GitHub page back in time, saw that there was a bunch of repositories that used to exist, but that had been since deleted. We looked at when they were deleted, and it would kind of lined up with when the Magic Cat software was starting to get released. So okay, maybe he's trying to like clean up his online presence a bit. Not sure. And then at also one point, the name was changed. So this was it was this account, and then changed the name on GitHub to the one that you just saw on the last slide. We went on to the Wayback Machine. This was new to me, but if you click on URLs, you can actually get the list of files that were indexed, not just randomly clicking around and getting the, oh, sorry, this wasn't indexed. You can actually just see the list of what was saved. There was an archive that had since been deleted that had a tar file, so like a compressed directory. Open that up. In that compressed directory was a Word document. In the metadata for the Word document was an author. And if you translated those characters, you get that guy's name. We also went back to Telegram, and there were files uploaded by Darcula. And these were kind of like installation instructions, like user guides for how to use the Magic Cat software. And what do you know? You look in the metadata documents for those, same name.
So to summarize, what we had found was some phone numbers, a US phone number that most likely were belonging both to Trousseau and Darcula. We had an IP address associated to both Darcula and Trousseau at the same time. A lot of phone number hints for his different email accounts. What we wanted to find out now was his real phone number in his Chinese phone number. And apparently there is no standard on how you should mask phone numbers. So the phone number hint from PayPal and QQ didn't overlap perfectly, so we ended up with 1,000 possibilities. We could use OSINT Industries directly here, but it would probably cost a little bit of money, and it's an active service that will reach out, so it's not too efficient on this specific case. So we decided to look in database leaks to see if this person have an online presence. There's a good chance that his phone number have appeared in at least one leak. So we started searching the leaks to just get a list of possible accounts to look into. So from this, we found that among these 1,000 numbers, only 7 of them had appeared in a leak, and the third one we checked after going through the online leaks, we found an account that had a picture of a girl that we had seen before. Because on an Instagram account with the username my4chang, it was the picture of the same girl with the same edits that didn't appear anywhere else on the internet. We blurred it out because the picture of this girl is not related to the story. Using this phone number that we had found out is Yu Chang's phone number, we used historical whois lookup, and we got an address where he used to live back in 2018.
Yep. And then we're not sure exactly where he lives now, but at least according to that whois, he was from the Henan province in China at some point. So okay, summarizing everything. These are very conservative estimates. We didn't really put too much time into getting all the data. We were just trying to really gauge what kind of scale we're looking at here. There were over 200 impersonated brands. So just imagine every postal company for every country on the planet, minus China. And it was also plus like Apple and Amazon and all kinds of stuff. As you saw before, over 500 or 5,000 licenses had been issued. And each license can be used to multiple times, so you can kind of get an idea of what the scale is. There were potentially up to 600 individual phishing operators or scammers. The link had been clicked on 13 million times, not necessarily saying that everyone filled out their credit card details, but you could see that somebody at least clicked on the link. A very conservative number, but we could concretely see close to 900,000 stolen credit cards. And some individual victims lost as much as $10,000. So you can kind of, not everybody was that bad, but you can kind of get an idea about what the scale is here.
So this is the end of our story. We kind of kept to the digital realm, and we found out that this story was much bigger than a technical blog post hosted on our own webpage. We decided to reach out to the Norwegian state media that also worked with Bayerische Rundfunk and our ARD and Le Monde. BR is here with us today. And they were able to talk with the victims and confront the scammers, travel to where they operated, and do things that it would be out of our place to do. Like we left them to take over in the physical realm, and we felt that was the right thing to do.
Yep. So long and thanks for all the fish. The main photo in the middle here was obtained as part of that investigative journalism with the media outlets that were from the last slide. They were able to get this based on the data that we provided to them, blurred out some of the sensitive parts, but that we believe is the main developer, Yu Cheng Chong. The photos around are of some of the prominent scammers that were in the group. I highly recommend, if you haven't read, you guys can check out the story. A lot of if you really want to see the humans behind it and kind of how they operated and how the media traveled to Thailand, and you can read about it there. Highly recommend it. We're going to pray to the demo gods, but you can, if you would like to, you can scan the QR code. We have a live copy of the phishing software running. You can scan it, load it up on your phone, and then after a minute or so, I'll pull up what the backend looks like, and then you can see what it looks like as the operator basically can see all the live stream of cards coming in. Yeah. So they don't validate any information except for the card number. So they do the loon check. So basically just remember 42424242, and that should pass.
Yeah. You don't have to use your real credit card number.
Yeah, please. Yeah. So I'll leave it up here just for maybe 20 more seconds, and then give you guys a chance to scan it, and then I'll load up the page. Hey, it works. All right, so this is what the backend looks like. You can try and find, there you go. So what happens basically here, somebody types in their information, you can click on, see what they typed in, and then it starts yelling at you, and we don't have the audio enabled, but it speaks to you, it makes a lot of noise. And then, so basically what happens is after you click next, it sits with the loading screen. And what's happening during that loading screen is it's waiting for the scammer to choose one of these options, saying like, okay, now that you have a card number, do you want to prompt them for a two-factor code? Because you're sitting there potentially with your iPhone enrolling that credit card into Apple Pay, and then they're going to send a text message to your bank, and then the victim gets that text message, and then you prompt them to enter it back to the website. So you get to choose. There's a few different options here. You can kind of go through, click on each one. Maybe you get lucky, and then you get a two-factor code. And then maybe you can say, oh, card was declined, sorry, try again, and then you get another card and another card and another card. And there's videos like all over their Telegram group where they just kind of show off. Like there was even one where the guy was like, he was driving in a car that had one of the big screens, and he loaded up a web browser, and he was like driving down the highway, and he was just like, oh, I'm making all this money while I'm like just going somewhere. So it was kind of cool. How many do we have so far? Got a lot of credit cards. Yep. So, the outcome of what happened. So when the media, journalistic process, you contact who you're going to write about for a request for comment. They did this about a week before the news was published, and Darcula disappeared. He I think deleted a lot of his stuff. I think his Telegram account went away. And we were tracking updates to the software, and we didn't see any updates to the software after he was contacted.
And also he pulled down everything that was on the internet, the licensing server, the installation server, so everything was gone after he left.
Yep. Now, there's a lot of, we did not solve the problem by any means. There's probably, I'm sure some of you are still getting messages. Maybe it's not a post message, but maybe it's like Easy Pass or you have some toll something you still have to pay. There's about 4 or 5 other prominent groups that more or less have the same software. One that's a bit up and coming that got popular after Magic Cat went down was Magic Mouse. There was actually a message in the Magic Mouse Telegram group that said, hey, the mouse killed the cat, and they were kind of happy because everybody moved over to their group. So this is a screenshot of that software. A bit interesting. So a lot of these phishing kits they basically steal components from each other. So some of the front-end pages were stolen from Magic Cat, used in Magic Mouse. So some of the people tracking got a bit confused because they looked and saw references looking like it was the Magic Cat, but it's not, it's the new one. Kind of messy. We were trying, so this is kind of what we're looking into now. We were able to track that they have about 1,300 servers in a 1-month time span, so really large. And it's a rough estimate, but we believe that this group is responsible for up to 650,000 credit cards per month. So it's very much still an issue. And with that, thank you.